So this is the Dojo multi-agent system for multi-sport athletes. The way that this works, the problem it solves is that it's hard to train for multiple sports at the same time, and you need a coach who knows some expertise in those specific sports. So for me, here's what we got. This is an important view. We have a goals view. So I've set a goal to climb 13A by May 3rd, 2026, and also run a 3-hour marathon by May 3rd, 2026. So those are both, kind of hard goals. So I have to train for both of them. I have to be really deliberate about my training. Now, the cool thing about this is I can record all of my workouts inside the app. So I can basically upload a run, and then we can look at fitness. We can take a look over here. So these are all the running workouts that I've done. Yeah, 0 kilometer. Yeah, so here's one. Did a half marathon on the 6th. First half marathon in a pretty long time. So the cool thing here is that when I upload a workout, whether it's a run or it is a climb, I actually am also sending the data about that workout to the agent system. And the agent system process that, and they store it inside of a vector database. So my coaches, I have a running coach and I also have a climbing coach. And so those coaches have access to the vector embeddings of all of my workout history. Now, the central part is the coordinator, which sort of controls the other two agents. It controls the running and climbing coaches, and it asks them for information when it needs it. And it creates this, which is my workout plan, based on my goals and my previous workout history. It is able to autonomously create workout plans for me, so I don't have to spend any more time thinking about it, which is sick because I hate thinking about how I'm going to train. So I'll show you how this works. Basically, the client is just this iOS app, and then on the back end, it's just a fast API here. And so I'm going to run this locally. Okay, server started. So I'm running this just on the computer right now, but I've also got this deployed on Google Cloud Run, so it'll actually work anywhere, but it's a lot easier to show the logs just running it locally here. Now, okay, so let's take a look at what's going on in my progress. Right now, I have my defined fitness level and the coach-defined fitness levels for climbing and running are both not assessed yet. I've only uploaded one climbing workout. You can see it's a little moonboard session here. So let's see what happens when I upload a new running workout. So I'll add a run. It searches here. Okay, let's do this one because it was outside. 12K. Cool. Okay, I'm going to say running in the snow. It's a lot harder when it's cold and wet. And so, yeah, I'm going to submit. Okay, so it says workout save. So workout save, it's been persisted to the device's storage so that I can see that later on the phone. But you can also see at the endpoint here on the back end, it says received workout submission. Running workout for 12K, memory response added. So it's actually added my workout to the vector storage in Supermemory, which is cool. And so what's going on here after? It makes a coach query. So the running coach has apparently been invoked. It's searched for the documents. Okay, here's a big response. It's just updated the context. Okay, so boom, it's done. So now what's happening here? So let's take a look at the fitness tab. So actually it's just changed. It used to say not assessed there, and based on looking at that run, which I uploaded, and all of the running history that I've already added to the Supermemory API, it's not basing that just off this run. I had a bunch of other runs, but I deleted them so that I could start from a clean slate, at least on the device. But that's what we saw here when we scroll all the way up. Right here, what it did was as soon as I uploaded a workout, that triggered a loop or a agent run loop where the running coach was delegated the task of saving that memory and then searching for the other memories about my running history, looking at my goal, and then basically deciding what my current running fitness level was, and then updating the context. And the context is what controls the view on the device. So now it thinks that I am an advanced runner. I don't really totally agree with that, but it's, very generous of my running coach to tell me that. And so that works with both running and climbing. That happens every time I update a workout, so that description is always kept up to date. So now the cool thing is that it doesn't just do that for, its assessment of my fitness level. It'll do that for all of the view elements or all of the critical sort of like data components that make up this training app. So I can also go to the chat to chat with the coordinator. I can say, make me a goal for next month sometime. I want to be able to run a 5K in 20 minutes. And I will send. So we've got, okay, payload received. So that is a different endpoint. So we can see there's the submit workout endpoint, which we just saw how that works, but there's also the chat endpoint. And so the chat endpoint, instead of going directly to the coaches, which is how the agent run loop starts at the submit workout, the chat endpoint starts the run loop at the coordinator agent. And so the coordinator agent is given the message that I send it, as well as this class called coordinator agent context, which has my user ID, my goals, my current training plan, and my activity fitness levels. And I didn't need to add training history because that is managed by the coaches and they have access to the training history in the Supermemory. So I'll show you actually how the memory functions work. So this is Supermemory. This is the memory graph. So what we're looking at here is actually just all of the workout history stored in a format that is easily digestible by these LLM-based agents. So these central nodes that you see, these pills, are actually Supermemory has like a little legend here, which is cool. So these are documents. And so a document is actually like the JSON record of a particular workout in the structure that I've defined, but it generates a title and a summary on its own using its own like internal model. And so what's cool is you'll see these other nodes popping out. So there's documents and then there's memory. So this is a memory, which is basically an offshoot of that. So here's my running activity, detailed summary of a running activity performed November 9th. It's 8.2, da-da-da. And the memory is that the user's average pace during the run was 6.7 minutes per kilometer. And so you can see all these different connections. And so it's automatically, this is the really cool thing. So how does this work is in my backend here, we just have this function, save workout to memory, and a workout payload comes in with a user ID, a workout, and coordinator context. So a workout is just this. So it's got the date, the activity, user notes, distance, kilometers, average heart rate, elevation gain, average pace. And that's just a base model that I'm validating it so it can actually be turned into JSON. And so this is the thing basically that I'm actually sending. So I take this, make a new Supermemory client, and I'm making this memory that is just the user ID and then that workout object. And then I literally just, it's simple as that. You just send it, you give it the metadata because the metadata is helpful for letting it search. You can use the metadata as filters basically. And then Supermemory does all the processing to do the vector embeddings. And it also does this cool thing, like, so it'll show you these new memories, which are green, and then it'll also show you the stuff that's expiring or has been forgotten. Because it's sort of like memories are ephemeral, I guess, in a way, which is kind of neat. And so here's all the requests that I've made. So you have search, you have add. And so here's a request. So the query is like running. Oh, whoops, didn't want to do that. Container tags, running, and then the filter. So the metadata that I'm filtering for is the user ID. And then this is the response. So I'm actually getting that. I'm getting that back. So how do I make a request? It's so search workout documents. So typically what I do is I do both. I do search workout memories and I search for the documents, and then I return both. Not sure if that's the best way to do it, but it's the best way that I've found so far to get like a reliable amount of context, at least in the testing phase when I don't have like a ton of data in here. I think the more data you'd want to do a more sophisticated searching method. But yeah, so basically you set these parameters are all decided by the running coach. So if we look, okay, so search workout history, that's the function or the tool that the running coach has access to. So search workout history is able to call this tool when it feels like it needs to know more information about my workout history, specifically for running. So you can see it'll basically just query the documents first. It decides what these input parameters are. Then it'll query the memories with the same input parameters. And then I return the workout history so I return the documents and the memories that get returned from the Supermemory search. Then it'll go off and decide what it needs to do. So whether that's updating the context or just returning a response to the coordinator agent for, a chat question, like if I ask a specific question about my history. Okay, so it says I added a goal to run 5K in 20 minutes. Let's take a look. Boom. So there it is, which is pretty cool. That is an agentic UI element. Run 5K in 20 minutes. Deadline, January 31st. Okay. Nice. I've got 2 months to do that. It's pretty good. Now, the next major functionality and sort of the core piece of this whole thing is the ability for the coaches to make my training plan and update my training plan accordingly so that I don't have to manage that myself. So I'm going to say, make me a training plan for the next 4 days that has 1 climb workout and the rest focus on running. And so that's going to take a little while to process. But in the meantime, while we're waiting for that, I can show you the logs. So here's how the logs work. So this is the OpenAI platform for the Agents SDK, so I can see all of my responses. So this is the request that just came in that we can see, make me a training plan for the next 4 days, and we can, monitor the success of that. But let's take a look at the one that just ran. So done, I added goals to your context. So you can see the system instructions because it hit the coordinator agent first. Let's look at the previous responses. So user, make me goal for next month. Want to be able to run 5K in 20 minutes. So then it does a reasoning loop. Then it decides to call the get context function. So it actually reads the coordinator context, that class that I showed you here. It decides to read all of this. So it knows my fitness levels, my current training plan, and what my goals are. We can see the output from that tool call. So this gets returned to the LLM. Then it reasons a bit more. Then it calls the context updater agent. That's a different agent which is specifically in charge of just updating the context. The context is what controls those view elements. So it's this little guy right here, and that's it. All he can do is read the context and update the context. And the reason he's the only guy who can do that is because if I word wrap, you'll see that it is the only agent that has access to the context format, because this is a really long piece of JSON, which I can show you here. This is the format of the context, which controls, like, I parse this on the client side to do all of the updates to the view based on how the context updater changes it. And so to keep my context under control, like the more, you get context raw with LLMs, the more that they have, and I want to keep it easy. You can see I'm using GPT-5 Mini, so you really got to think about the context and what you're making a single agent do. You need to like be very careful about your scoping with these things. So anyway, it seems like we've gotten a response back here. What did he say? So it's written this. Okay, so it's described this to me. Want me to finalize the calendar dates starting today to add these to your plan? So I'm assuming it hasn't done it yet, and yeah, it hasn't. Yes, finalize the plan. Okay, so the payload, and so this entire chat history is going back and forth to the coordinator agent. So yeah, okay, so sometimes if you're looking at the current day's logs, they just disappear like that. It's really it's like a bug on the OpenAI platform right now. I hope they fix it. Okay, we can't look at those anymore, so we'll just have to wait. Okay, so it seems like the coordinator has finished processing my workout history. So it has called the context updater agent, and the context updater passed in this new context block, which is just following that format that I showed you before. And so it's rewriting all of this, it's saving it to the context, and then that is going to have to get passed back. Okay, it looks like that just came back in. So now we should expect to see a response showing up in Xcode pretty soon. Yeah, boom. So here is the new updates, and what did he say? Done, I finalized and added the 4-day plan to your training. Okay, let's see if it showed up. Plan. Cool. Okay, yeah, there we go. So we've got today is, oh well, it made me an extra day for yesterday. I think I've got the date. I've got my time zone wrong. But yeah, cool. Okay, and so when you drop this down, you see like the nicer kind of like stats about this. Okay, so ooh yeah, that's the cool thing here is that it can do double days. So it can actually like, there's the day, but then you can have multiple workout sessions within a day. So it's scheduled me for Friday's going to be heavy. It's an 80-minute climbing session and then also a 10K run. So that's going to be a tricky one. Oh yeah. It looks like this one was the other climbing session, which it didn't want to delete. It decided that it would keep that, the original. So I'm doing double climbing. Nice. Yeah, you can see these agents aren't perfect. They don't totally know, because I think I said somewhere in the context or in the prompt for the context updater to not delete old workouts unless they're updating them. So I think it was just, yeah. A lot of these weird agent-like bugs end up getting solved when you just use a bigger model. Like if I used GPT-5 instead of GPT-5 Mini, that probably wouldn't happen. And if I use GPT Nano, like GPT-5 Nano, then it would happen a lot more. But it's also just more expensive. So, it's kind of a trade-off. And it just takes a lot of tweaking. All right, that wraps it up. That was the Dojo multi-agent system for multi-sport athletes. It is a combination of several LLM agents with expertise in different areas, utilizing persistent vector memory to make informed decisions about your multi-sport training journey. It's not a finished product. There's definitely a lot of stuff that still needs to be fixed with it, but I think it's a cool demonstration of some cool new technologies like the OpenAI Agents SDK and the Supermemory API. So yeah, thank you for watching.